All right, here's what we got. Let's see if I can find the original function up here. The original function is this. 3x plus 2 over x minus 1 times x minus 2. We do a sketch on our calculator. It shows us this thing. We'd like to know where the bumps are. We don't know exactly where they are, but there's a bump in here somewhere, and there's a bump in here somewhere. Horizontal asymptote comes from the highest power in x, it being in the denominator, we get y equals 0. Because there's an x squared down here. Vertical asymptote comes from the denominator, cannot be 0, so there's 2 slices. 2 vertical asymptotes cutting through. So when I see my calculator screen and I put this information together, I know that I'm going to have a U-shape in here because there's only one x-intercept at x equals -3 right there. So this curve can't come up and around, or it can't cut through like that. It's got to stay on this side because there's a point right here on the y-axis that's negative. So that U-shape has to stay down there. There also has to be a bump here because the curve has to go through and then stick to the horizontal asymptote y equals 0. So it has to go down and then come back up and stick. Looks funny. Anyway, so we know there's 2 bumps. We know there's 2 bumps just from looking, just from the calculator telling us, which means the derivative is going to reveal at least two potential bumps because we know there's 2 real bumps. So let's take a look at that derivative. Here's the derivative. It's a difficult derivative because I have to do the derivative of the top, which is just 1, times the bottom, minus the derivative of the bottom, which is a product rule. Got a product rule here, times the top. So the derivative of the bottom is x plus 2 times the derivative of x minus 1, which is 1, plus the derivative of x plus 2, which is 1, times x minus 1. I have to multiply this all out. But I'm happy because if you look at it, this is going to have x squared. This is going to have x squared. This is going to have x squared. That means that I'm going to get two values for x, which is good because I'm seeking bumps. I'm supposed to get 2. So all we care about is the numerator. So I work it from here down when you're looking at it. I had to multiply this binomial out, that's this one. I had to multiply these 2, that's this one. And then I multiply these 2, that's this one. Combined like terms, and I got lucky, it factored. It doesn't have to. I could use quadratic formula if it doesn't factor. But I can see x equals -5 and x equals -1 is locations for bumps, and it fits my picture. I do have a bump, and it's happening over in here. I do have a bump, and it's happening over here, because this is -1, -2, -3, -4, -5. Everything fits together with the way I need it to fit. That's really, really good. So when you go to get the y-coordinate, where are you going to get them from? Right here. This will give you y-coordinates. All right, you guys. See you later.